Hello everyone. In this short video we're going to show you how to program a 2.5 axis part in VisualCAMc for Onshape. As you can see, I have my part loaded in Onshape, and it's basically a plate. It's got holes and some slots on it, and these are tapped holes in the middle. These are through holes here. So let's go ahead, and we've got our VisualCAMc app loaded. Let's go ahead and add an element tab for VisualCAMc. And you'll see that the VisualCAMc app loads. And we're going to select the default document in this part, Onshape part. Okay, so here's our part in VisualCAMc, and we're going to go through the steps to machine this part and using 2.5 axis and drilling operations. So we have a separate video on how to set up your part, so I'm going to just go through the process in this video, and you can refer to other videos for specific areas such as setting up part, 3-axis machining, etc. So we'll go ahead and we'll start by making sure our machine is aligned with our world coordinate system, and our machine coordinate system are all aligned currently. And the z-axis of the machine is pointing upward, and the x-axis is pointing to the right, and the y-axis is towards the back. So we don't need to change anything there. We'll go ahead and select our post. We're going to use a Haas post. You'll also know, if you watched other videos of VisualCAMc, we have over 300 post processors already defined for all the most popular controllers. So we're just going to use the Haas post since it's already loaded on our list, and we'll select Haas and pick close. So now for our stock, this is going to be plate stock. So, but we will go ahead and use a cylindrical shape stock. You can use both a rectangular stock and a cylinder stock. So we're going to set a cylinder stock, and you can set the axis of the cylinder to either X, Y, or Z. Obviously we want it in the Z. And we're going to leave it, we'll add some axial radial offset here, make it a little bit wider. We'll clean up this outside edge. Go ahead and save our stock. And we have our stock defined. We have our setup defined. So let's go ahead. This is an optional step. You don't need to do this, but I'm going to go ahead and add a work 0 as a touch off point, and we're going to touch off on our stock and at the top face of the stock in the center. And we'll pick save. Okay, so now we got our work 0. So what do we want to do first? If this was anything other than plate stock, I would go ahead and put a facing operation on top, but I'm not going to do that since the plate stock is already finished to the thickness that we want. So let's go ahead and let's do some of these slots. So we'll go ahead in 2-axis. We'll use the slotting operation. And for the tool, we don't have a tool yet, so let's go ahead and create a 1/2 inch, and we'll do this. Well, let's do this with a smaller tool, and I'll show you the cut patterns for slotting. Let's go ahead and make this a 1/4 inch tool. And we'll have it make it a high-speed steel, and those are all fine. We'll make this a flat mill, 1/4 inch diameter. Okay, so we got a flat mill defined. Feeds and speeds, we'll go ahead and leave these set to the default parameters. For the slotting parameters, we got a tolerance of 1/1000, a stock of 0. We're going to finish it right to the side walls of the slot. And you can change the direction of the cutting of the slot. We'll leave it set to natural. And we'll go ahead and do an offset of say 15%. And for the slot geometry, we'll go ahead and right click on our part edge and we'll get a change selection. So we'll select all of these slots. So for the cut levels, we're going to go ahead and set it to at top because that's where our geometry selections are. We're going to do a depth of 1/4 inch and we'll divide that up into 2 levels. And sorting, we don't need any sorting. For entry, we'll go ahead and do, let's do a ramp. And we'll do a ramp angle, a nice ramp angle of 10 degrees and a height of 0.5. Let's make that 0.1. And let's go ahead and we'll do a linear exit. And let's generate this. So there's our, you'll see that it does a high-speed cut pattern for your slotting by default. We have that step over pretty fine, so we can loosen that up. And also you can use a tool of the same size as the slot. Let's go ahead and double click on this and we'll change our offset to 40% of the tool. And let's generate that. So there's our, loosens up our cut pattern there for our slotting. And let's go ahead and double click and create a tool that's the width of the slot. So that would be a 1/2 inch. And everything else looks good. Let's make this 3, 2, and 1. We'll pick save. And we'll use the flat 1/2 inch end mill and generate. So you'll see that with the flat end mill, it just uses a single cut pattern at the required depth, of course. And for our entry and exit, you'll see that it does a ramp motion to get down to the depth that we need. So that's your slotting operation. Let's go ahead and simulate that. Okay, at a 1/4 inch depth, looks like we need to go a little bit deeper to get all the way through the part. So let's go ahead and exit there. And we'll go ahead and make some changes on the cut levels. We'll go down 255. And let's simulate that. So there's our simulation. You see the slots are cut all the way through now. And there's our 2.5 axis slotting. Now for our drilling, we're going to go ahead and select the hole machining drill operation. And for the tool, we'll go ahead and create a 1/2 inch drill. And for the machining regions, we'll go ahead and hit the space bar to deselect our slots. And we'll just select our drill holes, work our way around. Okay, so we have all of our holes selected. For the feeds and speeds, this is drilling, so let's slow this down. And for a clearance plane, we'll leave that set to automatic. This will be a standard drill. Well, let's do it a deep drill, and we'll set a peck increment. Our drill depth is going to 0.25, and we're going to add our tooltip to the depth to make it a through hole. And where's the location of the geometry? It's at the top, and we'll do set a short dwell, and we'll leave the stack increment at 0.25. We'll just do 2 pecks to get through that hole. Sorting. If you got a lot of holes, you might want to do some sorting to optimize your machining time. So let's go ahead and do a minimum distance sort and pick generate. So here's our 1/2 inch drilling operation. You'll see that it drills all the way through the part, and it's a minimum distance sort, so it's going to just work its way around to drill these holes. Let's go ahead and simulate that. So if you want to slow that down a little bit. Okay, so there's our 1/2 inch drill. And let's go ahead and we'll do our perimeter and our interior. So we'll do some profiling. And we'll select our outer perimeter. Select, and we'll just use our 1/2 inch flat mill. And we'll do the tolerance set to 1/1000. Stock is at 0. We're going to finish it right up to the edge. And we're going to use determine using 3D model. So VisualCAMc will determine which side to cut. A total cut width is 0. It's going to make one pass at multiple levels. So the location of the geometry is at top. The total cut depth is 0.255. And we're going to divide that into multiple levels. And we're going to have a entry, a lines and arcs entry, and we'll apply that entry to each cut level, and we'll do an overlap to get a nice clean edge. And for exit, we'll just leave that to lines and arcs as well. We'll set our arc fitting, and let's go ahead and generate. So here you see we have a profiling operation on the outer perimeter. And let's go ahead and simulate that. Speed that up just a little bit. So there's our perimeter cut. And let's go ahead and create our interior cut. We use the same tool, flat and mill. Everything else should be the same. Location of cut geometry is at the top. Our total cut depth, 255. 2 cut levels. No sorting, entry and exit. We'll leave that set to lines and arcs. And let's go ahead and set entry and exit at each cut level. And if it'll overlap 1/4 inch. Cut arc fitting, and let's generate. So there's our perimeter on the inside. Let's go ahead and simulate that. So there's our interior perimeter, and let's go ahead and do our interior cut pattern here. And we'll go ahead and create a drilling operation. And let's select these holes. And for the tool, we'll change that to a drill that is 5/16. Okay, we'll pick save there. And then we'll also, everything else looks okay. Let's go ahead and generate that. And let's go ahead and simulate that. Okay, so there's our tap drill, and let's go ahead and create our tap. And we'll go ahead and select the tap operation type. For the tool, we'll go ahead and create the tap tool. So it's a 3/16 tap, or 625 for the pitch. And everything else looks okay. We'll save that. And for the parameters, it's going to be let's make that a PEC tap. The PEC tap depth. So 255, say, our location geometry is at the top, and we'll do a right-hand tap, and we'll do a PEC 0.1, and sorting will be minimum distance and generate. So here is our tap drill operation, and let's go ahead and simulate that. So there's our tap drill. Now let's go ahead and post this. So we'll post the entire setup. And here's our G-code for the Haas controller. Setup 1, there's our slotting operation. And there's our tapping and our drilling operations. So that's it for now. Stay tuned for more videos of VisualCAMc for Onshape.